Welcome everyone. Today we're talking about the ping pong cannon lab. Today we're going to be measuring both the velocity and acceleration of a ping pong ball when fired from this ping pong cannon. In this procedure, we will be using a ping pong cannon which has been supplied by Dr. Caviness from the physics department. The objective of this project is to find the velocities and acceleration of a ball leaving a ping pong cannon with various amounts of pressure, and we will determine how they correlate to each other. We will run a total of 5 trials and determine whether there is a linear relationship between the change in pressure and the change in final velocity of the ping pong ball. Additionally, we will examine whether the relationship of change in pressure and change in acceleration is linear.
This procedure includes the following apparatus: a laptop, a ping pong ball cannon, ping pong balls, Pasco, photo gates, a pressure sensor, a meter stick, stands to hold up the cannon, a vacuum, a piece of tape, scissors, and vacuum tubing. There will be 2 different equations that we will need for this procedure. The first one is the velocity equation, which we will use to calculate the initial velocity of the ping pong ball near the beginning of the tube and the final velocity of the ball while it leaves the tube. The change of distance, delta x, is the diameter of the ping pong ball. The change in time is the time each photo gate reads for the ball to pass, block to unblock time. The second formula, which is the acceleration equation, will be rearranged to solve for acceleration of the ping pong ball between photo gate 1 and 2. To begin with this procedure, we will need to set up the cannon. We will be placing a photo gate at the beginning and at the end of the cannon. We will also need to set up a pressure sensor and vacuum tubes, and be sure that there are no leaks in the hoses. Make sure that the photo gate sensors are going through the middle of the tube so that the laser is detectable through the tube, which will redirect light beams to measure the whole width of the ball while passing through. We will also need to measure the distance between the first photo gate and the second photo gate, which we will need later to calculate the acceleration. Additionally, make sure that the cannon is level.
Next, we need to attach the 2 photo gates and the pressure sensor to the 850 interface, which will be connected to Pasco on your laptop. When calibrating the pressure sensor, we will use one standard. Once all of this is completed, we will create a table and a graph in Pasco. The graph is for reading the pressure, which can be read live. Make sure to set kilohertz to 10 to be able to catch the data points fast enough. The table reads the time it takes for the ball to pass through each photo gate. Once we have Pasco set up and the sensors have been calibrated, we are ready to go. We can start with our first trial. Make sure to have something at the end of the cannon to protect from damage or injury. Additionally, be aware that the cannon is very loud. Here is an example video of what firing the cannon is like. 3, 2, 1.
Once we have finished the first trial, we can head over to Pasco and look at our table. As you can see, our photo gates capture the times it took for the ball to pass through each photo gate, and we can use these times with the diameter of the ball to calculate the initial velocity and the final velocity. For each trial, we found it best to change the pressure inside the tube by 10 kilopascals. To do trials at different pressures, launch the cannon while the cannon is still sucking the air out, and then launch right when it hits the pressure that you're attempting to launch at.
Here's an example of what your time should look like. These are based on the 5 trials that we took. Note that the time is written in as changed in time, because this is the amount of time that it took for the ping pong ball to pass through each photo gate. For velocity 1 and velocity 2, we use the aforementioned velocity equation, dividing the diameter of the ball by the change in time from photo gate 1 and photo gate 2. Now, with these 2 known velocities and the distance between the 2 photo gates, we can use the above equation to calculate the acceleration for each of our 5 trials. These are the examples that we got from our trials.
Once we are done with all the 5 trials, we are able to insert our data and create graphs in Excel. In our first graph, we will be graphing the change in pressure versus the final velocity. Be sure that your graph looks similar to this one that we have. The second graph, we will be graphing the change in pressure versus the change in acceleration. Note that the acceleration is negative. This is observed because there is still air inside of the tube. When the ping pong ball pushes through the tube, it is hitting against the air, thus slowing it down. This is why we had to do increments of 10 kilopascals in our experiments, because once we get to about the halfway mark of 60 kilopascals, it struggles to go all the way through the tube.
We concluded from this experiment that the velocity and acceleration of the ball is linearly correlated to the pressure we launched it at. We came across some error in our procedure from not being able to accurately read the pressure inside the cannon, as our pressure sensor was located in the vacuum tubes. Another source of error is the pressure change inside the tube. That is, that the pressure changes gradually rather than instantaneous throughout the entire tube as the ball is launched. As you perform this lab, please be careful and happy experimenting.